Good morning, it's Brian here again. This is the Art of Startup War. Again, this is another phenomenal company that we have invested into. We love some companies because they have the ability to grow and because they have the ability to make money and they have the ability to give shareholders return. And if we weren't interested in that, we'd be a pretty lousy accelerator and institutional investor. However, we love companies more if they can do that, plus they can make a massive impact in the world. And you're going to hear today about a company that are going to help deal with probably one of the most debilitating and difficult diseases that has hit itself on top of us. It is not COVID-19, but to the folks who are inflicted with it, it kind of feels like it. And it's something very real and has been around for a long time. And I had the privilege of meeting this team and really understanding how they've gone through their journey to get to the place they're going to come to. I have no doubt in my mind that this company is going to be an absolutely massive company. And I also have no doubt in my mind that this company is going to have a huge positive impact on human life, mainly African Americans and folks who are in Africa, but then also other people around the world as well. Tim, welcome to the podcast.
Thanks, Brian.
Thank you, Brian.
So can you tell me a little bit, and I don't know how you want to break this down for who answers, but talk to me a little bit about the genesis of the idea. Talk to me about KovaDx and where it came from and why you believe that this is so important to bring out to the world.
Thank you. So basically, my name is Yao, and I practice as a physician in sub-Saharan Africa. And during that time, I treated a lot of patients with sickle cell disease and also red blood cell diseases. And during my time as a clinician, what I did realize is that most of the diagnostic solutions available were not only expensive, but they also took a lot of time. So for example, you need a diagnosis and it will be so expensive, the patient themselves cannot afford it. And then on top of that, you'll probably get results in like 2 days. And then on top of that, you need highly skilled personnel to do it. And so when I eventually had the chance to move to the US and had the wonderful opportunity of meeting Tim, we spoke about using AI to solve some of these problems, and that was what led to the birth of KovaDx. So KovaDx, basically, Kova stands for strength and resilience, and the DX stands for diagnosis. And so we are providing very resilient diagnostic tools for people with sickle cell and red blood cell diseases.
So, can you, before we go into the dollars and the cents and how we turn this into something incredible, can you speak a little bit to sickle cell and exactly how it affects the people who are affected by it?
Thank you, Brian. So sickle cell disease is a genetic disease. And so basically what that means is that it's inherited from parents. Mm-hmm. And then once you inherit this defect, it actually affects mostly the red blood cells. So the red blood cell for like the average regular person has this nice disc shape. But people with sickle cell disease, the reason why the disease is called sickle cell is that the cell, instead of having this nice round or disc shape, becomes like sickle shaped, more like a half moon. And so because of that, it affects how the blood moves in the blood vessels. The red blood cells become sticky. It blocks the blood vessels, and then this leads to a whole lot of problems. For example, if the blood can't flow to the bone, then that means that the person will be prone to osteomyelitis and bone infections. If the blood can't flow to the brain, then they're going to end up having stroke. Some of them end up having like heart attacks, and it just creates a very painful life. So most of them spend their time constantly in the hospital, and it's just a very painful condition, especially when it comes to what they call the sickle cell crisis.
And why does it affect Africans more than other folks around the world?
So primarily, there's a lot of research that has gone on in this, but one of the major hypotheses is that sickle cell actually developed as a form of natural selection to be able to deal with malaria. So actually, people who just have one copy of the gene, because sickle cell actually in genetics is known as autosomal recessive. And so what that means is that you need 2 copies of the gene to actually have the disease. But the people with just one copy of the gene, people like me, actually are much more resistant to malaria. And so they are less likely to have malaria. But then once you have two copies, then it ends up becoming like creating all those problems. So actually, if you look at the epidemiology, you realize that the distribution of the disease is actually distributed along, the tropical regions in sub-Saharan Africa and places with a large Black immigrant population.
Fascinating. And how many people, more or less, are we talking about who are afflicted with sickle cell?
So globally, you have up to 200 million people
Wow.
having the sickle cell gene, and in terms of those with the sickle cell disease, we have close to 20 million people having the disease.
Incredible. And what do they do now? So I want to go to what you're bringing to market, and then, but before we get there, let's look at what's available now to treat people.
So first, obviously, before you treat, you have to diagnose.
Mm-hmm.
So as of now, they do an initial screening test. If you're lucky to be born in America, then most babies have a screening panel done for them once they're born. But in some parts of sub-Saharan Africa, because the tests are so expensive, the baby wouldn't be screened at birth. Instead, the baby would have their first screening test done when they basically come in sick and basically in pain. So once that initial screening test is done, they're able to basically sift out the people who have the gene and those who do not have the gene. But once they determine who has the gene and who doesn't have the gene, they basically have to do further tests to determine the specific type of gene the person has, since that basically has an influence on the prognosis. And so they do what you call an HB electrophoresis, which is one of those tests. And then that basically screens the patient and then they treat the patient. But the problem with this approach is that number one, it's not a point of care solution. It takes time, it's expensive, it requires skilled personnel. But more importantly, once the patients are diagnosed, in terms of monitoring, the physicians normally base it off patient symptoms and reported examined signs, and then a bunch of different tests. And the KovaDx difference is that we are building a single predictive tool that will be able to have predictive influence on how well the patient is doing. And that is very phenomenal.
Wonderful. And I want to get to that. I don't know if you want to have Tim explain a little bit about how that works, but maybe let's look at what you've brought out with KovaDx and let's look specifically the differences. And what I really want to get to is the difference in outcome, because I believe that there are some companies that VCs will listen to and they'll say, I love this, we're going to invest in this. And then there are other companies that VCs and family offices listen to. And I particularly want in this one that the family offices who are out there who want to have legacy and to be able to positively affect the world after they leave, I want them to hear what you're bringing to the world so they can see how they can get involved. So maybe either yourself or Tim, just tell us a little bit about specifically what you're building and maybe talk a little bit about the licenses that you're bringing out and what it contains, and then talk about how you're going to implement. And then let's look at the world in the future, 3 years' time, and then let's look at the world today and compare them both for folks who have sickle cell disease.
Thanks, Brian. So in terms of how things work today, in America, you have babies, like Yao said, getting screened at birth, but in many developing countries, especially across Africa, you have many people that can't afford the screening either at birth or even later on in their life, because the tests can be pretty expensive, around $60, which though for an American might seem pretty cheap. If you're making only $1 a day, that's quite a lot of money. So there's a lot of people who just find the diagnostic test to be totally inaccessible to their income. And because of this, they actually can't get the treatment that they need. They can't get the help that they need. They can't get the treatment regime and the plan that they need to best help them in their lifestyle going forward. So that's kind of what you have on the diagnosis side of things. The technology that we're building is bringing the price down to just a couple dollars, $1 or $2. So the difference between $60 and $1 when you're making around $1 a day is huge.
Yeah.
In terms of the monitoring, like Yao mentioned, that has huge impacts. Well, really everywhere it's being used. So across the country nowadays, as well as across the world, when someone comes in, because of a sickling crisis or because of they're coming in for their regular checkup with their doctor, and the doctor wants to find out, how well the sickle cell patient is doing. There's a whole bunch of tests that are done, but none of them give you a very clear answer. The doctor's kind of trying to combine a bunch of pieces of information from a whole bunch of tests, like how many blood cells a person has, what their platelet levels are at, things like that, to try and decide, how well the patient is doing. But a lot of times it's a pretty hard determination to make. And another huge consideration is the pain of the patient, which is, a pretty hard thing to quantify.
Mm-hmm.
Because a lot of times the patient will come in and be like, yeah, I'm in pain, but, expressing that pain to the doctor can be pretty challenging. Like, how bad is the pain? Normally they just say, on a scale from 1 to 10, where's the pain? So a lot
6.5.
Yeah,
what does it mean, right? Yeah.
Yeah. So having a quantitative monitoring device that gives you a quantitative index into the health of the patient's red blood cells is huge.
Huge.
Because not only does the doctor have a good understanding of how that's changing over time to see, like, okay, I'm seeing, like, 2 weeks ago, the health of the red blood cells was a lot better than now. It's consistently going down. We need to change things. Not only do you have that, but there's even the possibility of having predictive capabilities in terms of saying, oh, with the current trajectories, it looks like if we don't do anything, you might have a crisis in 2 weeks, 4 weeks, something like that. And you're also getting a quantitative understanding of where the patient's at the day, like right when they enter the hospital. You're not waiting days, not waiting hours. You get their blood drawn, you run it through the device, and okay, this is exactly where you're at, and then the doctors can decide a much better treatment option for them.
So I want to ask you my favorite question of this entire podcast, which is where you get to quantify your why. So we know that 20 million people around the world have got sickle cell disease. We know that that's only going to continue as life goes on. We know that the vast majority of those get diagnosed way too late. And we also know that there is not a great process in place right now to be able to analyze the progress of that disease when it has been diagnosed, all of which you are looking to fix. So if we look at those 20 million people, what does that look like going forward as far as what difference you are going to make in the world? If you look back in 5 years' time, what will the population look like compared to how it was before?
Thank you, Brian, for that question. So if you read the scientific literature, you actually realize that 50 to 80% of people with sickle cell actually die before the age of 5.
No.
And so, yes, that is a very atrocious data set, And
that's horrible.
So, yes, very, very horrible, So by having a diagnostic tool and a monitoring tool for these patients, the under 5 mortality rate is gonna fall down drastically, and even outside improving healthcare, under 5 mortality rate is one of the key indicators of economic progress. And so this will help in alleviating poverty from, a lot of countries.
So I invested in you for a number of reasons. And one of them, some of them very logical, and then one of them very woo-woo, right? So my logical reasons were an incredible set of founders, phenomenal skill sets, deep experience, not just in sickle cell, but across the board as far as being able to create and build diagnostic tools, right? That to me is tremendously important. So I know the team is able to execute. Now, I want to talk in a second about what that execution looks like, but I know that the team is able to execute, both you and Tim and the rest of the team that you have there. I also really liked the area that you were in. I genuinely had no idea that the mortality rate was that high from sickle cell. I believed it was lower than that, and actually that's like the saddest statistic I think I've ever heard, that something is too expensive to bring to a region, but 60 to 80% of people's little babies are going to die before they reach the age of 5 years' time. It's just like heart-wrenching for me. But I did know before it was a problem that needed to be fixed. But then I also believe this can become, a great product which will make a great return for all investors who are involved. So it ticks all of my boxes. My woo-woo reason was, and I think I told you this, was I was going for a run and I was just randomly running in Santa Monica, and there's some random dude cycling beside some lady and they're talking and the guy's like, somebody's got to find a solution for this damn sickle cell disease. I'm going, what the F? Like, I've run in a million places at a million times with a million people and nobody has ever mentioned sickle cell. So I called one of our due diligence guys and I'm like, listen, this is going to sound crazy, Victoria, but I'm also going to do this deal because that may have been God speaking to me. Like, this is such an insanely higher cause. And I know from this moment, like, no venture capitalist is going to talk to me ever again. But I believe your cause is so high that if you can even achieve a fraction of what you're looking at, if even one child, never mind like taking it from 80% mortality, which is just too much for me, but you even take it down a little bit and one parent ends up being with their child afterwards because of this diagnostic tool, you will have led one of the most meaningful lives ever existence, and Tim and everybody else in your team, and by the way, the investors. And I want to make it really clear, this podcast is for investors. So the people who are listening to it want to get a return on their money. Not only am I sure we will get a return on our money, I am sure we will get a phenomenal return on our money, but I will also sleep so well in the knowledge that we will have impacted an entire generation in such an incredibly positive way. So all of that being said, I want to talk about the machine. I want to talk about where the original patents came from. I want to talk about what you're building. I want to talk about how you're going to create it. I want to talk about timescale. I want investors to come off this call and to realize this is not just an incredible team building something that the world needs. This is a fait accompli. This is happening. So share with me, either yourself or Tim or however you want to split it up, on what you're building, how it's going to be built, a little bit about your academic background as well, because I think it's very relevant, and what our timeline looks like.
Great. So in terms of the device and how it works, you have this microscope component, which images the red blood cells. You have the cartridge, so the blood is collected from the patient, put into this cartridge, which separates the blood out and dilutes it a little bit so that it can be imaged better. The cartridge is then inserted into the device, which images the red blood cells to get these 3D morphological images using a new type of microscope called quantitative phase imaging. Those images are then taken and passed through our AI models, our deep learning networks, which then perform the classification to determine whether or not that patient has sickle cell disease, and if so, what type of sickle cell, as well as the health of those red blood cells. All that information can be obtained by these AI models. That information is then displayed on the screen of the device to be seen by the doctor, the nurse, and shared with the patient, and can also be sent to a remote healthcare platform as well to be stored there for access at their leisure. So we're using a lot of new technologies here, this quantitative phase imaging, which is relatively new, and is quite impressive, as well as these proprietary deep learning models that we've developed to process this data and to be able to identify from this data whether or not the patient has sickle cell disease.
Incredible. And how much of this is built and how much of this is being built, and what does the timeline to completion look like? In my mind, I see a kind of a George Clooney coffee machine where you put like a little capsule into it, but instead of getting your coffee, you're getting a diagnosis of sickle cell, which is a beautiful image for me. But talk to me about the timeline of building this and how close is my image to accuracy?
Yeah, the device is about the size of a toaster, maybe a little bit larger than a toaster, so it's pretty small. In terms of how the progress is going so far, we have an exclusive patent option on the microscope. We found just the microscope that we needed for the job. This specific microscope that we're talking about uses some new technology, a close to common path geometry, so that whereas the traditional quantitative phase imaging microscope has to be used in a lab setting with these expensive air-floated tables and these boxes to keep air from blowing through and messing the whole setup up. This is a much more robust situation, so it can be used just in any room on any table works great in developing countries. We found this specific patent because we knew it's what we needed. So we have that exclusive patent option. We're about to patent the device itself, or start the patent process for that. Just about to file that. We're just assembling it and getting ready for the data collection right now. We're thinking that we'll be starting the data collection in about a month. So we already have finalized the contract with the University of Cape Coast to do data collection there, and we're looking to finalize our contract with a couple universities here in the U.S. within the next few weeks. So those are going just right on track. And then once we've collected the data, then we'll have been able to train our models, our deep learning models, and proven that this, the whole setup works with how we've designed it. And then from there, we can kind of perfect it, design and create the product, get it through the regulation process, which will take some time, and then start selling.
Wonderful. So we're talking about getting to market possibly in about 3 years, 3 to 4 years.
Yeah, maybe I'd say 2 to 3 years.
Incredible, incredible. Such a huge thing. And maybe speak a little bit about your academic background as well.
Sure. So myself, I have a medical degree from University of Cape Coast. I practiced in Ghana, and then I moved to the US. I did a master's in bioengineering from the University of New Haven.
Great thing. And yourself, Tim?
Yeah, so I'm just going into my third year of PhD at Yale University in the computer science department there. My research is in the realm of robotics, so we use a lot of AI in our work. And I came here from University of Washington, where I was for my undergrad career. And yeah, it's been great. A great years in school. I love learning.
Beautiful, and such a prestigious and incredible school. And this again is what I want to get across to investors here. Like, we've invested in this company because we believe that the team has got phenomenal skills, background, and education, and the ability to be able to execute this in a very strong way. We believe the product is one whose time has come that will go to market. And again, if I'm going to repeat it once, I'm going to repeat it 4 times. If you have the ability to be able to reduce the mortality rate of little babies who are under the age of 5 years old from 60 to 80% mortality rate, all the way down to a much lower figure, this is something that you have to look into. And then the final point that I just want to touch on is so we can speak to the investment that you're going to need to raise, and then also talk a little bit about the potential revenues that you can bring in from this.
Sure. So as at now, after our pre-seed round, which we are done with, we are doing our seed round, which is going to be between 1.5 to $2 million.
Mm-hmm.
But after closing that seed round, we are using that to basically finalize the product we have, collect more data, and basically get regulatory approval and go to market. And our main sources of revenue, there are actually multiple streams of revenue here. The first one, obviously, is the cartridges, which basically has the razor blade model. So for the sale of each cartridge, we make some profit on top of it, which is more like a subscription source of revenue. But also for the sale of the hardware device itself, there will be some revenues. And then we are actually also planning in the future potentially to have research partnerships with drug development companies that are doing research on developing treatments for red blood cell diseases.
How interesting. And when you look at the subscription-based nature, like, how would that work exactly? Just to give investors a feel as to what the potential revenue could be for the company.
So you have the disposable cartridges, being used for every test. So you need one cartridge, obviously, when someone's getting diagnosed with having sickle cell or not. And that's pretty much you have every single, well, the goal is for every single baby that's born to get this test done, right at birth. And then you also have the recurring tests that are done for those that do have sickle cell disease. They generally come into the hospital between 2 and 12 times a year, averaging about 6. So you have 6 times a year they're coming in, for the regular checkups, as well as, if they're having a crisis. And for every time they come in, they get this blood test done. They need one of those disposable cartridges for that. And for disposable cartridges, we can sell them, like I said, really cheap. We can make them even cheaper. So
Beautiful.
we'll be able to get some.
And Tim, you don't even need to go any further than that. As people listening to it, and it's funny, even before, as I was looking at the market size, I thought, oh yeah, it's great. It's a good market size for a product which changes the world in a beautiful way. And I thought, yeah, 20 million people, but actually it's not. It's every single African who is born anywhere should be getting, at least going through the diagnosis. And then after that, it becomes the 20 million people on the subscription, right? But up front, it's about everybody everywhere. So again, I reinforce, you have got Yale graduates. You have got a product which is changing the world. You have got the opportunity to stop little children from dying. You have a market which is the largest emerging market in the world. Like, there's no other market growing as quickly as the African market is right now. And there's probably, I'm not sure about the birth rate, but I would guess that the African birth rate is in the top percentile in the world of birth rates. So from a monetary perspective, this thing is an incredible idea, and I'm so pleased I'm on it. From I gave back to the world and left it a better place perspective, and you don't get involved, there's something wrong with you. And from a team perspective, by not getting involved with an executing team like this, again, you're making a huge mistake. So I'm speaking to all investors out there. Get their deck, get their details, do what we did, put your money where your mouth is, and invest in a company that's making a tremendous change in the world. Yo or Tim, do you have anything to add to this? Anything that maybe I've missed out? Any questions I haven't asked about the importance of what you're doing or the future traction about what you're doing?
I think one thing worth mentioning is even the opportunities for expansion. So starting with sickle cell, which is obviously a huge market, both in the US, but especially across the world. But since this is a platform technology that we're building, once we start with sickle cell and get that up and running, then we can expand to other blood morphological diseases as well, providing the same fast, affordable diagnosis for a variety of blood morphological diseases, all from the same device using the same cartridge.
Incredible. Yo, anything to offer, anything to add to that?
I'll say that what we are doing is very incredible, and we are asking for as much support as we can get.
Okay, beautiful. And you're going to get it from here. Please share your emails and the website address. And you already know that here at Expert Dojo, we are your absolute #1 fan and supporter. And what we're doing here on the podcast, we are going to echo everywhere. The world cannot miss out on this phenomenal opportunity that you're bringing to them. So please share your email and websites. And I don't just want investors listening to this. I want anyone who can add to this conversation to reach out, whether you're mentors, whether you're exited entrepreneurs, whether you're investors, or whether you're people who can just create connections within health systems throughout Africa. Yo, please share your contact details.
Sure. So my email is yaw, Y-A-W, at KovaDx, KovaDx.com. And our website is www.kovadx.com.
Wonderful. And Tim?
Well, I'll respond to a bunch of email addresses, but probably the one I check most often is my Yale account, which is tim.adamson@yale.edu.
Okay, beautiful. Gentlemen, thank you to you. Thank you to your team for what you're doing. As I mentioned, I couldn't be happier to be an early investor in your company. Let's make this thing the greatest thing that people talk about in 5 or 6 years' time. Thanks for being on the podcast.